Okay, so at the start of the lesson, I proved the co-function identity for the sine and cosine using right triangle trig. And that proof wasn't really valid for all angles on the unit circle. It was only valid for triangular things. So this is kind of nice. We can actually prove this identity using the angle addition formulas and subtraction formulas. Now, it's a little bit strange because I haven't actually proven these identities yet, so we shouldn't get too excited about it, but I will do that at the end. All right, so let's start with the left-hand side. The sine of pi halves minus theta. So I'm going to use the angle difference formula. The difference formula for the sine to break this down and to try to see if I can get it to look like this. So for sine, it's sine, cosine, cosine, sine, same sign. So the sine of pi halves, cosine of theta, same sign, cosine of pi halves, sine theta. Sine, cosine, cosine, sine, same sign. Draw our unit circle here. We're looking at pi halves. That ordered pair is 0, 1. So the sine of pi halves is 1. So 1 times the cosine of theta. I don't know what the cosine of theta is. Minus. Now the cosine of pi halves is 0. And the sine of theta I don't know. But it doesn't really matter what the sine of theta is because 0 kind of wipes it out. So as you can see, this simplifies to just the cosine of theta. And what's a little bit interesting anyway is that this works for all angles, not just angles between 0 and 90 degrees. Okay? Okay, so that's that proof. Example, evaluate the sine of theta minus phi when the cosecant of theta is negative 7 halves and the tangent of theta is negative. The tangent of phi is equal to 2 over 1 when the sine of phi is also negative. Rationalize the denominator. So I'm supposed to evaluate the sine of theta minus phi. Okay, well I don't know anything about this angle theta minus phi. These are for thetas and these are for phis, but I have nothing about the actual difference of those two angles. But if I use my identity, sine is sine, cosine, same sign, cosine, sine, sine, cosine, cosine, sine, same sign. So now I've got it written down into sines and cosines of each of the individual angles, and I need to know what those angles are. Now granted, I do know the cosecant of theta, so I should be able to find the sine of theta really easily. But how do I find the cosine of theta? Well, let's look at each of these angles individually and draw them in the correct location with the correct triangle. Okay, so this diagram is going to be for the angle theta. So the cosecant is negative. Remember, all students take calculus. So if the cosecant is negative, then the sine is negative, so it can't be in these two quadrants because that's where the sine is positive. The tangent is less than 0, so the tangent is negative. Tangent is positive in this quadrant, so we must be in quadrant 4. So let's draw a triangle in quadrant 4. Make sure the reference angle goes up to the x-axis. Now I don't know what the angle theta is, but I do know that this is theta reference. And if the cosecant is that, then the sine is negative 2 over 7. So that means the sine is opposite, so 2 over hypotenuse, 7. And since it's down, we'll call that a negative 2. Pythagorean theorem to find the last side. Do this off to the side and then erase it. 2 squared, negative 2 squared is 4 plus x squared equals 49. X squared equals 45. X equals plus or minus the square root of 45. I think that's got a 9 in it. 9 times 5. So the x coordinate here is positive 3 square root of 5 because it's in the positive direction. Okay? So now I can find the sine, cosine, tangent, sec. I can find anything for the angle theta. That's going to give me this one and this one. Now let's do the same thing with the angle phi. Tangent is 2/1, but it's positive, so all students take calculus. It's a bad phi. Good phi. Tangent is positive, so it could be in this one, could be in that one, can't be in those two. And the sign is less than 0, so the sign is negative. Well, sign is positive here, sign is negative here, so we're in this quadrant. Quadrant 3. Draw a triangle. Again, I don't know phi, but this is reference angle phi. Tangent is 2/1. Tangent is SOHCAHTOA, that's opposite, so that would be 2/1. Now, it's supposed to be positive, but these both need to be negative. Negative x, negative y, you divide them, you get a positive 2. Find the hypotenuse. Pythagorean theorem, 2 squared is 4, 1 squared is 1, equals c squared, so c is equal to plus or minus the square root of 5. Then we always make the hypotenuse positive so we don't screw up our signs. Okay, now I can find anything for the angle phi. Now I'm ready to go back to my original problem. The sine of theta. Sine of theta is negative 2/7, using this one. Cosine of phi. Got to go to this one, the bottom one here. Cosine is adjacent over hypotenuse, so that's negative 1 over square root of 5. Minus, maybe I should put these in parentheses, I don't know. Minus cosine of theta. Cosine of theta is 3√5/7, 3 times the square root of 5/7. And then the sine of, oops, no, I did theta, I'm doing it right here. Now the sine of phi is negative 2 over square root of 5. There we go. So I use the identity to break it down into individual angles. And then I use these triangles in my old trig to evaluate them all. So I end up with positive 2 over 7√5 minus plus minus is plus 6√5 over 7√5. So that gives me 2 plus 6 square root of 5 over 7 square root of 5. And it told me to rationalize the denominator. So let's multiply this thing by √5 over √5. Square root of 5 over square root of 5. So I get 2 square root of 5 plus 5 root square root of 5 times square root of 5 is 5 times, that's 30, over, this is 5 times 7 is 35. Oof. There we go. I'm thinking of, wonder if I can type this into the calculator to test it out. We're at 8 minutes. Yeah. I think we'll end the video there and go on to the next example. All right, I said I was going to stop the video and go on to the next one, but I do want to show you how to check this with the calculator because I think it's kind of neat. So this is my answer. Now this would be hard to type in the calculator because we can't just type in theta and phi. However, if the cosecant of theta is negative 7/2, then you could solve that for theta by saying the inverse cosecant. Now we never really talked about the inverse cosecant, but it exists. And then phi is kind of like the inverse tangent. Now these aren't necessarily true because theta and phi could be different angles, like these are the reference angles. Like how you get to that angle is unknown. Like it could be this angle, or it could be, let's go backwards 3 times, and then stuff like that. But the thing is it doesn't matter when we take the sine of it at the end. So if I wanted to check this answer, I can take the sine of this minus this. So I typed that into my calculator. I took the sine of the inverse cosecant of, well, there should be a negative here, of negative 7/2 minus the inverse tangent of, is it positive or negative? Positive. If I hit enter, it gives me that. If I go to menu, algebra, factor, last answer, why did it do that? Did I hit control enter? I did hit control enter. Weird. So it's am I off by a negative sign? All right, what am I doing? Oh, did I go? It's theta minus. Oh, that's right. All right. Well, I'm not so exactly so sure why this is giving me the opposite of the sign that I need. All right. So I kind of tried to get a little too smart for my own good here, perhaps, and tried to check with the calculator. I'll just, I'm not exactly sure why I'm getting the wrong signs, other than to say that when you take the inverse sine of theta here, it does put us in this quadrant. However, when you take the inverse tangent of this angle, it's supposed to put you in this quadrant, right? So I'm thinking that the reason my signs aren't matching up is because these inverse functions are a little bit wonky, but it kind of gives us the same value, kind of a little bit maybe. I guess more of the story is maybe don't check these answers in the calculator like that. Okay? All right. We'll finish up the notes in the next video.